screen?
Yes.
Okay. This is the title of my presentation. I will give the motivation of this work, that is the current research of the group of automatic control of the Polytechnic of Bari, and the approach that we will provide to for the introduction of connected, cooperative, automated mobility in the real traffic. And some application on about artificial intelligence in a different context, for instance, route planner, intersection management, carpooling, and some implementation in a current project. The motivation. The motivation is accelerate green and digital transitions, and in mobility sector, the European Commission in particular give very importance to the digitalization of transport by focusing on automated mobility. Automated mobility is a connected, cooperative, and automated mobility. And what means that? It means that we have to use vehicles, cars that are not driven by people. They are autonomous, but very important things, they are connected. And they perform cooperation between other cars, other vehicles, and between the infrastructure. The objectives. The objective is in particular increasing safety and reducing environmental impact. So fully automated driving will be present in our road, with this expected significant improving road safety, traffic efficiency, comfort of driving, and emission reduction. However, even if in particular the European Commission would like to obtain a very large number of this kind of vehicles in the next year, there will be a transition period where conventional vehicles will share the road with this kind of new vehicles, with connected and automated vehicles. So it is important to develop traffic management strategies to maximize the traffic environments. I'm sorry, I don't know if you earn this noise. There is an alarm that started in my department. I hope it is not too
No, it's not.
too strong.
We don't.
No, it's okay.
No,
it's okay.
Okay.
It's okay. Thank you.
So the approach that we would like to use for the integration of this new mobility in the real traffic. The approach is enhancement of physical, digital, and operational infrastructure, with important impacts for the society: safety, reducing number of road accidents; environmental, reducing transport emission and congestion; and inclusiveness, ensuring inclusive mobility. Indeed, this kind of new vehicles can be used by all people. For instance, people, all vulnerable road users. So we start with the physical infrastructure. Indeed, the cities must consider new tools, the application of new strategies, such as dynamic dedicated lanes for autonomous vehicles, analyzed intersections and intelligent traffic lights, intelligent road signs and cameras. In other words, it is necessary to introduce in our cities distributed sensors. Now, second, the operational infrastructures. These infrastructure are very important because it is necessary to provide new governance models to allow this vehicle to travel in our cities with new rules, new laws, new regulations. These are very important aspects because without the introduction of this new regulation, it will be not possible to introduce this new mobility. Now, the main aspect that today I would like to present include digital infrastructures. Each city has to start with the existing traffic management systems, and it is necessary to update these traffic management systems with external servers with high level of automation. And this is possible, for instance, implementing services that are based on artificial intelligence, using connectivity also that are based not only by 5G connectivity, but also with 6G technology, that is new technologies that has been implemented in order to increase the connectivity and the safety of the connectivity for this mobility. Now I would like to present some new services that we developed by artificial intelligence tools that are devoted to route planner for traffic balancing, alternative less congested roads, road selection to decrease the traffic congestions, unsignalized intersection and intelligent traffic lights, and carpooling services. These are the services that we would like to introduce and that we develop considering new technologies that are artificial intelligence, in particular machine learning and deep reinforcement learning, digital twin, and communication based on vehicle-to-vehicle and vehicle-to infrastructure. Now, new service based on artificial intelligence technologies. I start with optimized route planners. For these autonomous vehicles, it is necessary to select and to optimize the route, not only considering the normal goal of minimum path length, but also minimum number of right and left turns for the intersections, because for an autonomous vehicle to turn on the left, for instance, is a little dangerous. So it is better to minimize the left and right turns. Maximize the number of priority lanes. Indeed, in some cases, it is possible to travel in priority lanes, so it is better to select this kind of lanes. And the path with less traffic. The optimization that we proposed are based on artificial intelligence, in particular deep reinforcement learning. For the young people that are not used to apply this kind of tools based on artificial intelligence, I would like to recall some why we use deep reinforcement learning solution for the control or for management purposes. And you can see in the left the standard controller that where you have the controller, the system, and the observer. And here in the right, we have the controller that use artificial intelligence. Indeed, the artificial intelligence use the action on an environment that we would like to have a goal, a particular goal, optimizing, for instance, in our case, the best route. And the agent that is the tool that perform the action on the environment perform the action. The environment has its state, and on the basis of the action performed by the agent, the state changes. In order to in order to say that the action is a good action or is not a good action, then we give rewards for good action or penalty for the no right action performed by the agent. And this concept can be applied also to our controller, where the plant is identified by the environment. The controller is identified by the policy that the agent has to apply. And the reinforcement learning is the means to approximate the policy that the controller have to apply. So the idea is not too far from the idea of our feedback, but the agent in this case is implemented by a set of tools, a set of software that allow us to obtain an agent that perform the right actions on the environment. This is just to give an idea of our artificial intelligence tools. In our context, what is the environment? The environment is the city with the street and the intersections. So the environment is, in our case, modeled by a simulator of urban mobility, that is SUMO. And the environment is modeled by a network that is composed by nodes, junctions, and intersections, and edges. In other words, the city street. The action space are performed by the agent, but the agent is in this case associated to each vehicle. So the agents are autonomous vehicles, and these autonomous vehicles can perform their action, go straight, go right, turn on the right, turn on the left. And the state of the agent of the vehicles is described by latitude and longitude of the position of the vehicle, the hidden angle of the vehicle, and the age occupied by the vehicle. The goal is implemented and realized by the rewards. And we have to minimize the distance between current age and destination age, avoiding left and right turns, using priority lanes, using roads with less traffic. So these are the global rewards that we have implemented. And to optimize the route planner, we have to consider a set of tools. As I said, we have to consider the simulation that is Sumo, the OpenStreetMap for obtain the map of the city and implement this in Sumo, Python to implement the action the action that the agent have to perform and to train the agents. Indeed, the agents to obtain a good performance of the agents must be trained. Then an analysis must be performed before the training, select the map on OpenStreetMap, manipulate the Sumo Python, and so on. In particular, we divided the map in zone and we perform a clusterization of the zone of the city by using K-means algorithm. And the traffic is realized and implemented by obtaining historical data by TomTom API. Three simulation scenarios are considered in different time, pickup time of the city. And then we determine the possible route in Sumo. The agent is trained with about 1,000 episodes. Indeed, they are 150 macro episodes, each one of 10 episodes. Obviously, it is necessary to train the agent with a strong number of episodes, but you can see that the rewards are good because the agent is trained when the reward reach the maximum value. In this case, you can see the reward at the beginning of the training is low, and when the episodes increases, the number of episodes increases, the level of the rewards are high. And just some results. You can see in the left the route that is suggested by Google Map. It is a starting point, a final point. On the contrary, this is the route that has been suggested by the artificial intelligence. And it is different. It is avoid congested road, and it prefers dedicated lanes. So it is a route that is longer from the route that suggested by Google Map, but the time to reach the destination is minimum. I introduce now another service for unsignalized road intersection. And in this case, we consider intersection where traffic lights are not present. And we consider connected vehicles that are also in this case agents, automated vehicles, and connected priority vehicles. These automated vehicle and connected priority vehicles that can be ambulance and police car are connected between each other and are connected with the infrastructure. And there are also regular vehicles that are not connected. In this context, we perform a service that the agents, the connected agents, have to apply in order to avoid the collisions and guarantee the priorities for automated vehicles and ambulance or police cars. Also, in this case, we use artificial intelligence. And you can see we consider an intersection. In this case, it is a simple intersection where blue cars are connected, and there are also regular vehicles. So we consider the system a system that is not observable, fully observable, because we don't have the connection with regular vehicles. And we consider this as an enlarged road intersection, and we apply a control strategy that forces the autonomous vehicle to regulate the race speed in order to ensure priority and prevent collisions. Also, in this case, the environment is implemented by Sumo and OpenStreetMap, and the action space are applied on the vehicle actions that are vehicle acceleration, deceleration, or keeping current speed. Because also in this case, obviously, the agents are vehicles that apply the action on the environment to obtain this goal that is not avoiding, in particular, avoiding collision, and give priority to autonomous vehicles and priority vehicles. The zone of the intersection is divided in two zones. This is an approach that is applied in different contexts, in different applications to manage the intersections. There is a control zone where connected vehicles share data and information. For instance, plan route, current speed, current distance to the intersection, current distance from the in front vehicle. And the merging zone where that is the area of potential collision. Obviously, the decision must be taken in the control zone. And as I said, this is the action space and the reward. The reward are based on the velocity of autonomous vehicle, velocity of priority vehicles, and a big penalty, obviously, is given for collisions. And this is the training of the agent. And also in this case, the collision do not increase significantly after about 300 episodes. And this is a simulation just to see that the blue vehicle is with priority, and after the training, the priority are guarantees. This is a different simulation. No? This is a different simulation where a traffic light is implemented in the contrary in this case, where also in this case the traffic light give priority to the autonomous vehicle and the priority vehicles. You can see this is also traffic light that are implemented by by artificial intelligence. And you can see that when red vehicles arrive, the traffic light become green. Now, the last service that I would like to present, also in this case, we apply artificial intelligence. It is a service very important, very innovative, because it will be the future of mobility. It is based on autonomous vehicles that are shared by users. In this case, vehicles no longer owned by individuals, and the autonomous vehicles is like a taxi, but it is a particular taxi because they can be shared by the user, and the user can call the autonomous vehicle, and obviously there is a set of users that have an initial point and a goal position of the city. And the artificial intelligence has to maximize the safety and comfort of the travel and minimizing the travel time, but also considering the optimal distribution of pick-up position of the passengers and the drop-off positions of the passengers. In other words, we have a set of users. Each user has a particular pickup position and a destination position, and the carpooling service has to optimizing the travel of the vehicle, guarantee safety, comfort, and minimizing the travel time. The benefits of people are, in this case, a large number, because guarantee road safety, because the vehicles are not driven by human, but are autonomous. Traffic efficiency, comfort of driving, because as we said before, we minimizing the turn on the left, the turn on the right, so we maximizing also the comfort of driving. And we decrease the emission because the final goal is also reducing traffic and increase inclusiveness. Indeed, this kind of taxi, this kind of vehicle can be used by all people. And then also in this case, we consider autonomous vehicles that are agent. The training of the agent is performed by Sumo, the simulator, and the model is very similar to the previous model, but the training is more difficult than before service, because it is necessary that the pickup of people, of a person, must be planned before the drop-off of this person. And the agent must learn this service. That is not easy. So we give the strategy of negative reward with a penalty for each delay in the travel, penalty for each not feasible sequence, user pick up after user drop-offs, and a routing algorithm optimizing the routing. So we have these two strategies, one for the carpooling service and training the agent, and the second one for routing, for optimizing the routing. This is the training of the service and the training of the agent. Also in this case, it is necessary about 1,000 episodes, a very large number of episodes, because the training is not easy in this case. But you can see that we reach a very good strategy, because we reach a very good reward. Now, after giving the presentation of these services, I would like also to show some implementation of the services that is implemented in a current and ongoing European project. That is a project involving 20 partners, European partners, and of 10 European countries. The Polytechnic of Bari is the coordinator of this project. And in this project, we have the implementation of the described services in 4 living labs, where the services are implemented in the field. Indeed, in this case, the services are implemented just by few vehicles, because the experimentation in Europe is limited, is very constrained by the rules and the strategies for safety that are good rules, obviously, but they are very important, because they are the starting point for the implementation of these services in our cities. And you can see 4 living labs: Tampere in Finland, Trikala in Greece, Turin in Italy, and Vigo in Spain, and 2 followers living labs, where the application of the service are implemented by the simulation campaign. And these are Bari in Italy and Quadrilatero, that is a zone of the Portugal. In this follower living lab, that we call follower living labs, we amplify the results of the lead living lab by increasing the project outcome dissemination, and also to increase the impact of the outcome of the project. This is the demonstration of Tampere. In a zone of Tampere, you can see the zone where the implementation is performed. And we have a service for the traffic lights, where the velocity of the vehicles are regulated on the basis of the traffic light. And there is also a new service for parked vehicle detection. And this is an automated shuttle. You can see this automated shuttle that travel in the city and detect by front camera the parked vehicles, and it is able to avoid also vehicles that are not parked in the right position. This is the living lab of Vigo in Spain, where intelligent traffic lights are implemented. and traffic light that give us, I said before, give the priority to the priority vehicles, in particular to the autonomous vehicles. And this is the autonomous vehicle that travel in the Gran Via of Vigo. Also in Vigo, this is a demonstration of the vehicle that is able to give a warning if a pedestrian is detected. I just give more. Okay, here there is a pedestrian that have to cross the street, and the vehicle give a warning for this pedestrian. And this kind of vehicle are a level of safety, obviously, that is higher than a standard vehicle. This is a demonstration in Turin. I would like to show this demonstration because it's particularly interesting, because the travel of the vehicles are detected and followed by a digital twin. There is a digital twin in the city that check the travel of the vehicle, and if the vehicle is in a street with a high level of traffic, the digital twin give a message and give a new strategy, give new messages in order to select a new route. So it is there is Sumo connected with the digital twin, and Sumo start the rerouting process and provide a new route that guarantee a better route with less traffic. And yesterday I was in Turin, where this service has been implemented in the real traffic. So, in conclusion of my talk, I would like to increase your research and your interest in this new mobility, connected, cooperative, and automated mobility that is focused on the interest of the European Commission, that is in period started a set of project in this area. And in order to guarantee good travel of these autonomous vehicles, new tools, new application, new strategies must be applied. Artificial intelligence strategies is one of the new strategies, but also digital twin, as I said before, and new strategy, new communication strategies, for instance, 6G. There are some new projects that apply 6G strategy, 6G technology to increase the communication in automated mobility. So future research is to continue to go in this direction with these technologies to implement this new kind of mobility. Now I presented the results of our current research, but it it is not only my research, it is the research of my laboratory group, and that is composed by professors, PhD student, postdoc researchers. And I have to thank my group for the result of that they reach, and obviously I am proud to lead this very, very good group of researchers and professors. And this is a photo on my house, because every year we organize a party in my house, typically in summertime, because our group is very strong group, very close, and it is necessary to have a very strong collaboration, and I am very happy to present also my research group. Okay, thank you for your attention. I hope that I am stay in the right time.
Yes, Maria Pia, thank you very much. It was very nice, your presentation, very interesting. And I ask people, students, researchers, if you have comments or questions, please feel free to talk and ask Maria Pia.
Oh, thank you so much for your excellent presentation. Thank you.
Thank you, Amanda.
You're welcome.
No comments?
Questions?
I have just one curiosity. I don't know if I missed at some point, but when you talked about the reinforcement learning approach, so this is a kind of distributed reinforcement learning approach, in the sense that each car or each agent will learn the policy autonomously. So it's not a centralized approach in which you collect the data and learn the policy in a centralized way, right?
No, it's by now we consider just an agent. In other words, yes, it's okay that each vehicle is an agent, but we develop only one agent. So yes. We are trying also to develop more complex strategies where the agents can collaborate each other in order to optimize the solution.
Okay, perfect. Thank you.
Okay.
And a comment from, so if understood well, in this living lab, you have applied it also on real traffic
yes.
situation, not only with Sumo and simulations.
No, yes. The services are realized by Sumo, by the simulation, obviously, but then they are implemented in the real traffic in a different context. For instance, in Tampere, that is in Finland, this is possible in the real traffic, and also with some limitation in Turin. In other cities, for instance, in Vigo, the application is performed in a dedicated lane. As I said before, the rules for allow the travel of this vehicle are different in different countries. So this is a necessity of the research in a different context, but the research must be also for develop new rules that can able the traffic also between different countries, because By now, it is not possible. But a lot of new, this is the result that I presented is about a project that will close in October. So we finished the project, but we start another project where the fleet of vehicle will be implemented in the real traffic. So the path is very long, but the European Commission push the Europe to go in this direction.
Okay, very interesting. Okay, other question, comments? Don't be shy.
Thank you, Professor. Thank you for your presentation. So I just wonder if the security or resilience could be considered also in this project, or it could be the further point could integrate with this real application, real traffic application. How do you
Yes,
think?
yes, thank you, because it is the main problem for using these vehicles, the safety. And indeed, a lot of people ask us if these vehicles are very safe. And indeed, the research for increase the safety of these vehicles that are autonomous, but they increase safety also in the standard vehicles. Indeed, you can see that the number of safety tools are very high in the new cars, in the new vehicles. So the research is very important in this field, and also in our services you consider the safety as a very important aspect. And it is an aspect, for instance, reducing the number of turns on the left, on the right, is a safety rules.
Thank you. Yes.
Yes.
Okay, if there are no other comments or questions, we thank again Maria
Thank
Pia.
you. Thank
And,
you for this opportunity. Thank you very much, Laura.
Thank you to all the people that attended it. I know that Friday afternoon sometimes is not a good choice, but we decided that is usually many of us are more free on Friday afternoon. So it's always very interesting to see many people connected, and we don't know before. So okay, Maria Pia. So we switch off the camera now, and as I was saying before, we will put the recording of your talk on YouTube, and we will send it on LinkedIn.
Thank you.
Advice. Okay.
Thank you.
Bye to everybody.
Thank you. Bye.
Bye. Thank you.
Bye.
Thank you all.
Bye.
Bye.